Perfect. Well, thank you for that great introduction, Tom. And yeah, thank you for coming to listen to me speak. I feel a little bit of an imposter, if I'm honest, because I'm not going to have much LabVIEW in here, but hopefully it's close enough that we'll see something relevant for everyone in here. So, a bit tongue-in-cheek, my title is NI LinuxRT is open source, so what? And what I want to do with this, there's nowhere near enough time to get into how it all works and how to do everything that you can do with it. What I want to leave you with today is hopefully a bit of either inspiration, if you want to try and do anything that I talk about, or at least a bit of a better understanding of when you're working with NI's LinuxRT targets as to what's really gone into that and how it works. So, yeah, I mean, as Tom said, I've been around in the LabVIEW community for a little while. I'm a CLA, CLED, and a LabVIEW champion. I've been using LabVIEW since 2008. I run my own company, Wiresmith Technology, where I build systems for research and development, either new instrumentation systems or kind of validation systems. And just to color some of my interest in this, I actually work a lot with Rust nowadays. So that's kind of what pushed me into this path, as we'll see as we go through. And so what I want to show you today really is we're actually going to start a little bit of the basics of what is a Linux distribution. We kind of need to understand that, and building my mental model of that has really helped me with this whole process. We're going to talk about the Yocto Project, which is what NI used to build LinuxRT. I keep meaning to change this. What is open source sounds like I'm starting from the beginning. What I mean by that is what do NI provide that is open source, that is available? And then what are the benefits to the fact that we have that available? I want to start off with our giant's a female, as is very customary now at GDevCon, and I was struggling to think of anybody new because we've been through so many. But I did hear the news, unfortunately, last month of the passing of Dame Stevie Shirley, so although I'm sure she's been up here before, I felt it was worth revisiting. So if you haven't come across her story before, it's fascinating. I imagine she was a fascinating woman. She was actually evacuated from Nazi Germany on the Kindertransport to England. She didn't go to university because they wouldn't let her do the science that she wanted to do. She joined the post office and learnt to build computers and program assembly, but got fed up with the sexist environment. So she set up her own company doing software development, primarily comprised of women who were working at home with the flexibility to work around their home life. And that was hugely successful. They actually wrote the black box recorder for the Concorde software as part of that company. And she's done many things since. So yeah, certainly it's an interesting story, worth reading up on. So I haven't got graphical code, but I've tried to keep it a bit whiteboardy. And I've tried to adapt some diagrams and structures I've seen to my mental model. You may find things differently, but this is what's really helped me understand and get into the world of Linux. So I should say I've been kind of tangentially interested in Linux for a long time, using things like LinuxRT, and probably the last 6 months I've been daily driving it, which has really helped to kind of build this understanding. And the first question is, well, what is a Linux distribution? So NI LinuxRT is a Linux distribution. We hear a lot about Linux running the world. It's in your phones. It's on the web. But the story is not quite as simple as that. The Linux project itself is just that kernel. It is the piece of software that is going to talk to your hardware and provide interfaces to what's generally termed user space software or user land software, so that it can access the resources of your hardware. What a distribution does is take that kernel and package it up with a whole series of software on top to build an overall environment. The core important part of that is the C runtime library. That's what most stuff will then interact with the kernel through. And on top of there, there'll be system binaries, system libraries, and bundled applications. And the reason that this distinction can be important is, one, you'll find one Linux is not necessarily another Linux. That was one of the problems I had when I first started trying to tinker with LinuxRT. The other thing to understand is all these distributions have their own reason for being. So the value they add is they're going to say, for example, let's take Red Hat. Red Hat wants to provide an enterprise Linux. So they want kind of long service life, extreme stability, and they're going to package everything up so it's compatible. So what a Linux distribution does is it takes the kernel, it's going to build the C runtime, it's going to build all those packages on top of the exact runtime that's used in that environment. That's why you can't necessarily take LabVIEW for Red Hat and it'll run straight away on Ubuntu or any other Linux distro. That's why LabVIEW has to target certain distributions. At the other extreme, you might get distributions like Arch Linux, which is very much like a bleeding edge thing. As soon as a software's update, a new package is available. I tried one called Tumbleweed that was when I initially started running it on the desktop. But for me, for business, that wasn't stable enough. I liked it, I really enjoyed the experience, but I couldn't afford to have things breaking every now and again. So all these distributions are doing is they're taking that Linux kernel and they're building an ecosystem around it for their particular purpose. And that's exactly what LinuxRT is doing. It's saying we're going to take that Linux kernel, we're going to apply the real-time patches, and we're going to provide us a kind of software ecosystem for running around it. And the way they do that is with something called the Yocto Project. The Yocto Project, I still don't fully understand the structure and the history of all of it, I'll be perfectly honest with you. But I know there's a few key components. The big one being there is a tool called BitBake, which we'll see referred to a few times. This is a Python tool that's essentially a work scheduler. And that's going to take configuration files, and that's going to schedule the building of all the pieces that we need for a Linux distribution. On top of that, there's something called Open Embedded. That's kind of the base recipes and components that form the basis of most of these Yocto build projects. And then the Yocto project itself kind of provides this in a consistent way, and they do provide their own distribution that's like a reference to start from. I think that's about right. Don't shoot me if I've got that wrong. The reason I kind of diagrammed this out is Yocto projects have a diagram on their page, and it just confused me until I understood it. And now I understand it. So it kind of is helpful, but it was a bit too slow. So I prefer this simpler description that I found useful for my mental model. What the Yocto project does is we're going to start with a bunch of sources. So these are generally going to be source code. Because again, these distributions, the reason why open source and Linux is intertwined is they want to start from source code and build everything up in the same kind of package ecosystem. The first thing it's got to do is build the cross-compilation or the target compilers. So if you're running on an x86 system, but you want to target, for example, the Zinc C-RIOs, well, they run ARM, so you have to build a compiler that can run on x86 and compile to ARM. Once we have that, it can then take those sources and it can build them for the target system and build them into packages. On LinuxRT, those packages use the, I should have actually checked the full name of it, the OPKG package manager, which I now say that, I think, what does those stand for? The Yocto project can actually support different package managers, but that's the one that NI have standardized on. And I should say behind all of this, one of the things you'll see in this embedded world is it will be a bit different from a desktop Linux because they're often optimizing for size and power. So they will use smaller options, so smaller, simpler things like OPKG over, say, the Debian solutions. And once we have these packages, they basically get installed to a local version of the system to build images, or they can be built into feeds. And so that's what NI have done. They have started from the kind of base sources that Yocto provide, they've added layers of customization, and they've built out these systems. I'm not going to go too deep into this, but it just helps color some of the other bits we'll see. The way that BitBake works in the Yocto project is you start with layers. So you'll see this term as we look at some of the code. It starts with meta dash. And in those layers, there can either be new recipes, where a new recipe is a new package that we want to build, or they can customize existing recipes from a previous layer. And we'll see kind of BB files are sort of the base definition, and you can probably guess BB append says, I want to take the original definition and I want to just add some customization to it. I'm not going to go into all the rest, but that's the basic piece. And the reason that's important to understand is this is our avenue to kind of start tinkering a bit. So I do have some bad news, because I know what I thought when I first started getting into this, and many of you may be thinking this as well. It's like, oh, great, does this mean we can put LabVIEW real-time anywhere? So what is actually available as open source is the base image. This is what the Yocto project builds and what's available on GitHub. So you can build that for any target that you'd like if it's supported by the Yocto project, and you probably have a bit of work to do to get it on something a bit more esoteric. And you'll have seen this process if you've worked with RT targets in Max. You first apply a base image, and then on top of that base image, you install the runtimes that you need, so the LabVIEW runtimes, Veristan components, things like that. So those are still closed source. I totally understand why. That's NI's business. Makes perfect sense. What that means for us tinkerers, though, is it isn't as simple as, oh, great, we'll try and swap this onto a Raspberry Pi and we'll run LabVIEW-RT on Raspberry Pi, because we don't have the LabVIEW-RT builds, the runtime, the source code for those runtimes. So that's the bad news, I'm afraid. But let's get to the good news. So what are the benefits of this system being open source and available to us? I felt creative. I wanted to make it all rhyme, so I've used some strange terms, which are probably a little too strange, but I'll work through them. The first one is inspection. I found this so useful, not only here, but in so many other places where I'm using open source. When something strange happens, you can go in and look at how the system works. Protection. So if NI disappeared off tomorrow, I don't think that's going to happen, but if they disappeared off the planet, or they decided to change how they wanted to build compact RIOs, or you had some security issue and you didn't have time to wait for NI to react, you have all that source code so that you can take control of that system if you want. Customization. So as I say, maybe LinuxRT doesn't do out of the box what we want. Having this source code means that we can start to customize what that does. And I'll show you some examples of that in a minute. And of course, contribution. We can actually go back to NI and say, you know what, we think it'd be better if you built it like this. And they can choose to accept or not that recommendation. But I'm going to focus on inspection and customization, because I think those are the two most relevant in this context in terms of what developers might want to do with this. So let's start with having a look at what's there. So this is the link to the main GitHub repository for NI LinuxRT. And I'm going to see if my Wi-Fi has reconnected. It has, perfect. Let's see if we can just zoom that in a bit. So you'll find a couple of main repositories under the NI organization. The first one, kind of the top level one, is this NI LRT. This contains everything you need to build the base images for NI LinuxRT targets, so for PXI or for compact RIO. You can also take this and target anything x86. So if you've seen the explanations of how to run it in a virtual machine, it's based on exactly the same kind of thing here. Now, I'm going to ignore a lot of this, but I will just point out there's some very straightforward instructions on how to start building this. So you do need a Linux host system, but it uses this Pyrex tool which puts stuff in Docker, so it kind of makes it pretty reliable. And it gives you the full kind of set of instructions, say, great, this is how you build an image, this is where you find it. One thing I haven't dug into, and I haven't even really looked at what NI are providing here yet, is you can also use this to scan for CVEs and to produce software bill of materials. So if you need that or want to dig into that, you can do that through this as well. I haven't looked yet at exactly how useful that is. One thing I will say, though, is you do need a fairly capable machine for this, because this is going to download all the source code, from everything from the kernel up and build that on that system. I'm going to preface that to say I do not have some demos today, unfortunately, because of that case. I had a few issues, and then I tried to do it on the laptop last night, and I ran out of RAM, then I ran out of space. You need, probably, I would say, you want a couple of 100 gigs of disk space. And I found I had to bump the VM to 16 gig of RAM to have any hope of it running. So it's not a trivial thing to do, and it still took several hours. But yeah, do it before lunch or do it overnight. But if we go to this sources folder, so this is where those layers exist. So remember I said generally the layers start by convention with meta. So you can see at quite a high level the building blocks that have gone into LinuxRT. Obviously we have the open embedded course, like I say, that's kind of the baseline to everything. That contains everything like for dealing with the kernel, for example. We can see they've got the SC Linux packages in there, Qt5, which the LabVIEW runtime requires, I believe. Probably the one that is most interesting to us is Meta NI LRT, because this is then the customization layer that NI have created to build their distribution. Now there's a lot in here, and I'll probably get lost at some point. So I'm not going to try and dig too deep, but I kind of want to give you a sense of what this looks like so you can start poking around. For me, there's a couple of most interesting things. So if you remember in that diagram, we had layers at the top. Now we're into recipes. And you can see some of these recipes are kind of just customizing other layers. So the recipe for the kernel here, that's just applying customizations to the kernel layers that we've used before. Again, probably the most interesting one to us is the recipes-ni, because this is their kind of software utilities that they're going to lay out on top. And so in here, you can see everything that NI have done on top of sort of standard Linux, if you like. And this is quite important because when I've gone through the kind of been on the RT Linux forums, a lot of the questions end up coming to, oh, there's a bash script somewhere that does this. And I don't know that they're really publicly documented. NI are happy to talk about them, they're not a secret. But this is one place where you can go in and see and understand what's going on. I think the biggest one I've seen for that is the network configuration. And I don't rely on kind of a standard Linux network configuration utility. They have a few scripts in here of their own. So for example, we can see all the scripts in here for their net configuration utility. And then within here we have the BB file, so that's like the package definition. And then the files themselves, so in this case they're just all kind of bash scripts. And you can go through and see and understand how they work. Another interesting one I found as I was working through trying to get this running on different targets is they have a version in here of the FWPrintf, firmware printf. So what this does is prints variables that can be stored in the bootloader. The reason that's quite interesting is they then use those variables to identify what type of compact RIO it is. So if you're using the virtual machine version of this, it automatically comes out as a CRIO 903X, I think. You can then go in and tweak these variables to make it appear as a PXI system, make it appear as something else, which functionally doesn't change much, but it might make a difference in how Max kind of interacts with it. The other one I've found quite interesting is the system imaging. I was trying to find a good path to this earlier, and it's so long, I'll end up wasting too much time, but I've got a tool at the minute where we need to do more robust imaging. We worked with the RAD tool. We can't work with System Link because of the network architecture. So at some point, I'll be digging into here and understanding how that actually works. It's actually quite simple under the hood. It's pretty much tar zip and copy it off. The other thing that will probably be quite interesting if you are sort of tinkering around with this is then all the kind of scripts that they use to bring the environment up. So these are the init scripts of Linux. So for example, you can see how they deal with disks, how they auto-mount USBs, for example. Again, I'm not saying I have a particular use for this. I want you to understand that actually there is all this stuff you can go in and understand and see what's going on, whether that's just curiosity or you have a specific problem. And the other piece that's been very useful for me, which I'll show you while we're in here, is, I told you I'd get lost at some point. Let's come back up to here. Oh no, actually it's up 1. So the way that the Yocto project defines things, there will be a recipes core where they will define the images that are going to be produced. And within these images, let's choose the run mode. You can see the way that these images are built are from packages and package groups. So package group is exactly what it sounds like. You take a bunch of packages and say, we want to kind of put a wrapper around all of these. And so you can come in here and see exactly what sets of packages are being installed on Linux. And you can then potentially customize those as well. Which reminds me, this probably belongs later, but I forgot to put a slide in for it. If there is something you particularly want to run, there is a package index for Open Embedded. Again, different from Yocto. I still haven't fully differentiated the two. So for example, I've got an example later. If we wanted to try and put in Firefox, we can look in the recipes, and that will tell us what layers can offer that. So if that layer is already in the system, we can just add and build that package. Sorry, I ad-libbed that. I probably should have waited a minute, but let's see. All right, let's get back to the presentation and then. Which is, nope, not that one. I thought it would open a new window, and it has not. Ah, come on, mouse. Okay. No. Right. So that's what we can look at. The other thing we can do is customization. Now, I would say for 99% of people, this probably isn't going to be necessary. You know, NI know their use cases, and it's pretty well built for that. But I want to share a couple of use cases that I've explored as avenues as to why you might want to do that customization. So the first one is a real example that I've used. I wanted to see if I could get a Rust user interface running on a compact Rio. And it depended on this library, libxkbcommon. Everything else was there. This one library was missing. And because I could search in the bitbake layer index and see that was included in the main system, once I pulled that repo down, I just had to run this command, bitbake libxkbcommon. That builds the package, and now I can install that on a compact Rio. What I was hoping to demo to you today, but ran out of disk space, is the Firefox case as well. It's probably not a good idea to run a general purpose browser on a real-time system, but I have been exploring, well, what if we can have some web views for the kind of user interface on there? The other one I'd really hoped to show you, I shouldn't say, I said, maybe I should have allocated more time. I had so many issues trying to get this to build on my system last week, I eventually had to give up, is we should also be able to add drivers to the Linux kernel. So starting from there, you can create your own layer, and you can tell the Linux kernel to say, actually include the driver for this. So I've got a little miniature industrial PC that uses a network driver that isn't in the base image of the NI image. So it should be possible to take that, say, just include this driver in the kernel, and then it will run there as well, just like on the VM. Whether that's recommended, there's another discussion for another day. But I wanted to see what was possible. So that's a bit of a whistle-stop tour. I chose this as my summary because that's hopefully the face I want to see out there, is a bit of curiosity. You know, there's nothing in here that is going to change your day tomorrow. But I think it's good to understand what is capable, what are the things that NI are putting out there that will hopefully empower us to build more interesting systems over time. And even beyond that, hopefully you've learned a little bit about Linux as well. So I'm a bit short on time, but hopefully we've got time for 1 or 2 questions, if we've got some runners.
First of all, excellent presentation.
Thank you.
I do have one question. What would be the next stop if we would want to continue with this? If we want to create extra or add packages to it, where would you say this is where you should go to to get more information?
Yeah, so I think the starting point I've been working through is the Yocto Project do like a beginner training on YouTube. It's like 4 hours or something, but it really gets you the basics. And it's one of those things you look at it and go, oh, this will get you 80% of the way there. It's essentially a set of configuration files. So that's what I would do next if you're interested. There are a lot of training companies doing it as well. They tend to be longer and more expensive. I think that gives you a good starting point of what's capable, what's possible, sorry.
Wonderful, thank you.
Hello, James.
Hi.
Really nice presentation. What is the result of this bitbake when you run bitbake? Is the OPKG package?
Yes, yeah, so if you target a single recipe, it just produces a package, or then there are commands that produce the full system images as well. So it depends on, when you run bitbake in a name, what that's actually doing is say, go run the build for this recipe. So it depends a bit on what that recipe defines, but in most cases, it's a package output.
Thank you also for the nice presentation. I was wondering, I saw that there were no issues, no pull requests in the repository. Is National Instruments open for that, or do they just ignore them?
That I do not know,
Okay.
the answer to be honest. I also went to look to see, you know, they do seem to be building in public, if you like. It's not just, oh, every now and again we dump what we're doing. But I've not seen much external pull requests or anything.
It's of course edge case
Yeah.
technology, but I was just wondering. Thank you.
No worries. Perfect. Well, thank you very much. I will be around if you've got more questions, so feel free to find me.